So a few years ago, the industry starts to realize that accelerated hardware has become a necessity rather than an interesting option or interesting tool. So that's why we started a project called Cyborg, called Nomad at the time. At the time, the requirement coming from the telco land where the standards was drafted in the ETSI specifications, and didn't take us too long for us to realize the scope for Nomad is still too limited, because we have requirements from public cloud, machine learning, HPC, all those different domains. And we realized, okay, we might just start thinking it over. We started a project called Cyborg, and we renamed the project to Cyborg. And we are aiming to provide a generalized management framework for accelerators or any computing resources that are not traditionally known in the cloud, like CPU or memory. And we named this project after this superhero, Cyborg, because this guy just mixed up his organic and cybernetic parts to achieve his superpower. And we have, for the GPU, like we have the requirement from public cloud. They want to use GPUs in OpenStack, and nowadays GPUs can be used in OpenStack. Even as if you listen to the keynote this morning, vGPUs already been supported in Nova. So currently, if you want to use GPUs, so you define GPU-specific flavors and in the PCI path through extra spec. But regardless how you use it, though, you still have pros and cons. And you still need to tune out the KVM to achieve acceptable performance. That's why we want Cyborg. What do we want from Cyborg, though? Cyborg can. We want to provide an interface to be able to list, discover, and attach the accelerators has been added to the cloud dynamically. And we want Cyborg to be able to handle the driver installations or uninstallations in the cloud. Okay, and this is the overall architecture of Cyborg. So basically, what it does is it gets the report from the driver side and it saves the accelerator information in the Cyborg database. And this database is a nested tree structure. Using this structure, we can describe pretty much any type of accelerator structures that we want to support in the future. And then the Cyborg will interact with Nova to help Nova to schedule the accelerators. And by the way, Nova is still the one that does the heavy lifting. So Nova still does the attachment, and but Cyborg is doing the lifecycle management for Nova. It's pretty much the cinder for accelerators. In terms of timeline, over the last year, we started a project called Nomad. And then over the year in Barcelona, we renamed the project to Cyborg. And Cyborg became an official project later last year in Queen's PTG, September. And we have our first official release for Queen's February this year, which is a big milestone for us. Looking forward to this year, we will continue working on additional features and supports for the Rocky release. And we also talk with the Kubernetes communities to help them to be able to provide accelerators for containers as well. And this is a summary of our contributors. We have contributors from all over the places, like Huawei, Intel, Lenovo, all those players. And anyone is more than welcome to join us. We are very open to any contributors who wants to support this project. And for looking at the Pike release, what we had last year was this green part was what we had contained in the Pike release. We just built a basic framework that has a conductor, basic conductors. We also defined the REST APIs, and we have a simple Cyborg agent at the time. Oh, this is just a summary of it. And for Kring release, on top of what we have from Pike, we added a few more drivers for a few more different vendors' devices. For instance, we have the SPDK driver. We have also have an FPGA driver from Intel. We have a generic drivers support, but this is more like a neutral driver, but doesn't do much right now for testing purposes. We also have resource provider resource modeling in Kring release. This is the nested tree structure database I talked about earlier. And yeah, this is the summary of it. So for Rocky release, what are we gonna have? So the green boxes are the plan that we have. First, we want to have a Python client to help people use our APIs. And we will have a programming support for FPGAs. Well, it's a set of API that allows admin or users to be able to change the functionality on the FPGA dynamically without powering down the machine or anything like that. So it's a set of API provided to you. And we will have a quota control as well that helps to help people to manage the usage of the accelerators in the system. And we want to bring more players to the game. Let's say we are working with Xenix to get their support on their FPGAs to work in Cyborg. And we also have a roadmap on the OS ACC. What it does is similar to OS Brick that allows people to attach accelerators based on different protocols. It doesn't have to be PCIe. It could be an accelerator from Ethernet or even USB if you want. So it's just it's similar to what OS Break does. And we also have a plan to work with Kubernetes people to support accelerators for them. And this is sort of our preliminary plan for right now to utilize the DPI to interact with the Cyborg API over here. This is still very early stage. I don't think the plan is even finalized yet, but it's on our roadmap. And there's some other plans. For instance, we want to support Cyborg with the bare metals, and we want to support ARMs in the system. ARM as a heterogeneous resource in our system. And this is we're also considering in the Kubernetes world, we want to consider the CRD accelerator controllers as well. And that's it. And any questions? If you can also always go to our IRC channel to ask any questions. But that was quick. Oh yeah. No more questions? All right. Okay, I guess that's it.